Today we have a math problem. Say you have 25 horses. And you can only race 5 horses at a time, but you have to figure out the top 3. Well, how many races can you do it in? Answer in 3, 2, 1. Well, first we know you can definitely do this in 7 races. For the first 5 races, you divide the horses into 5 groups. And each group has a first, a second, a third, a fourth, and a fifth after the race results. So that's 5 races so far. Now, you see, these horses already have 3 horses beating them. So they are not going to be the top 3 anytime soon. So let's just eliminate them. And now we have these top 5 firsts. And let's race them. And one of them will inevitably be number 1, one of them number 2, one of them number 3, one of them number 4, and one of them number 5. And as I said before, 4 and 5 have no chance of winning. So out they go. Except that these are even worse than these. And since these have no chance of winning, these will have no chance of winning either. Now, if we want to make sure that something won't win, we just need to find 3 horses better than it. So this one won't win because this one is better than it. It ranked first while this ranked second, but this was third in the 6th race, and this was second and this was first. So there you go, 3 horses that are better. So this one is also not going to make it. And this one, since it's even worse, is also not going to make it. And for this horse, this beats, and this beats. Which means that this horse is also not going to make it. So now we have 6 horses left, except that since this one was the best of the best, well, this one, we know it's going to be a winner! And now I have 5 horses left. Well, you know what we can do with 5 horses? Let's put them in a race. First place of the race is second, and second place of the race is third. So yes, now we know that we can do it in 7 races, but why can't we do it in 6? That's the actual hard part of the problem. But let's start with a simpler problem. Say you only wanted to figure out the first, and you only had 6 races to do it. Now, how would you do this? Well, every time you race, you can race 5 horses, and 4 of them you know will not be first because they got beaten by the first place. So you can eliminate up to 4 horses per race. And since you have 6 races, and you can eliminate 4 horses per race, that means that you can eliminate 24 horses, which leaves 1 to be the winner. Perfect! But how exactly would you do this? Well, since you have 6 races and 5 horses per race, but there are only 25 horses, you'll have to overlap at some point, except that if you chose one of these, which you know already lost, and you try to race them with some other horses, well, maybe that one won't be the one that wins. And of course, you'll eliminate 4, except that one of them was already eliminated. So you'll actually only eliminate 3, you can't eliminate enough, and you'll fail. The only way we can re-race a horse is if the horse we are re-racing is one of the best horses. Because if that one loses, well, at least we'll still be eliminating this one. And plus the other 3 members of the race, well, that still eliminates 4, so that's fine. So now we have some rules. But will these rules still be enough to determine second and third? Well, you're going to have to re-race inevitably at some point, right? So, say these are the ones that you already won, and then you're re-racing them. Well, we don't really care if these are winners or not, so I guess we can make some of them winners, and no one here would really care. But what if we make a winner win? Well, we will still eliminate 4 horses, but the problem is that we have no way to compare whether this one is better or this one is better, because we didn't have that race. So we don't know which one is second. Now, of course, if this one lost, we wouldn't know which one is second, but we have to assume the worst case, which is that this doesn't lose. And the only way to determine which one is second is to race them. Except, no re-racing except for winners. Which means that we aren't allowed to re-race them unless we don't want to determine first. And if we can't determine first, well, we've lost. But if we don't re-race them, then we won't be able to determine second. And we've still lost. So this is impossible with 6 races. So the true optimal answer is 7.